along the southeast coast of Florida are sinking at unexpected rates.
And you can see it is empty right now, though it's typically one of the more popular spots here in South Florida. It was shut down yesterday.
Florida, rain likely playing a role in the massive sinkhole, returning now for a second time. This time, the gaping hole where a home once stood. That home swallowed by a sinkhole before, and the man who lived there.
A neighborhood in Central Florida suddenly looks like the cratered lunar landscape. Sinkholes are opening up and forcing families from their homes. Manuel Bajorquez says the problem is underground.
Under the intense glare of the sun and across the vast sweep of Florida's coastline, something deeply unusual is taking shape. Something that even veteran scientists struggle to fully comprehend. Above the calm shoreline, seabirds wheel and cry, unaware that beneath them, researchers now believe a profound transformation is underway. A shift not just in sand or shoreline, but in the very ground supporting Florida itself. This is not ordinary coastal erosion. It is not the delayed consequence of hurricanes past, nor the familiar, incremental rise of sea levels. What is unfolding is faster, stranger, and alarmingly disconnected from Florida's long-understood natural rhythms. The earliest warnings arrived quietly, as they often do. Subtle tremors were detected along the coast, barely noticeable, yet undeniable. Methane gas began venting upward from deep below, unexpected and deeply concerning. Unfamiliar acoustic signals echoed from within the Earth's crust beneath the continental shelf. Then came an extraordinary move. The U.S. Geological Survey issued a rare red alert, driven by newly analyzed data. The processes unfolding beneath Florida's shores had no clear precedent. Scientists investigating mysterious offshore sinkholes in the Gulf uncovered vast subterranean voids, abnormal fractures in the seafloor, and unsettling evidence that raised urgent questions about the future of the state's iconic coastline. Yet Florida is not alone in facing this concern. Coastal cities worldwide are watching closely, questioning how secure any modern shoreline truly is when confronted with unpredictable geological forces. As experts race to interpret the signs, one question resonates far beyond Florida's borders. Could what is happening here be an early warning of broader planetary changes still ahead? Imagine being instructed to activate a warning siren in the dead of night, without knowing exactly what threat approaches. That was the position facing the USGS. For decades, Florida's coastlines were regarded as among the nation's most stable, protected by gentle slopes and natural sand barriers. But new evidence shattered that confidence. Offshore sensors recorded seismic tremors rarely associated with Florida, a state far removed from major tectonic faults. At the same time, sonar surveys revealed widening fractures along the seabed, longer and more extensive than anything previously mapped. This red alert was not a response to past damage. It was a warning of active, ongoing subsidence and underground movement capable of reshaping the coastline. Scientists were forced to abandon the assumption that Florida was immune to sudden geological change. If a coastline long considered tranquil can destabilize almost overnight, then what truly shields any coastal region from unforeseen catastrophe? What hidden forces remain undetected beneath seemingly calm shores? Below the gently undulating waters of the Gulf, divers encountered a seafloor newly marred by massive underwater sinkholes. These formations did not fit the familiar pattern of sinkholes caused by slow groundwater erosion through limestone, a process well documented in Florida. Instead, these voids were vastly larger and deeper, spanning hundreds of feet and plunging into staggering depths. Most troubling was their speed of formation. Features that would normally take centuries to evolve appeared within a single season, their edges sharp and raw, as if freshly torn open. This suddenness shattered established expectations. If large portions of Florida's continental shelf can collapse so rapidly, far offshore and with minimal warning, what other failures might lie ahead? Beyond threatening marine ecosystems and navigation, these sinkholes demand a reassessment of how Florida's coastal foundation responds to unseen stresses rising from below. Just beneath the surface, clouds of methane gas are now venting into Gulf waters. under normal conditions, methane escapes slowly from ancient organic material locked deep within sediments. But scientists are now recording sudden, forceful releases. Each plume points to new fractures opening pathways through previously intact rock layers. The implications are serious. Methane alters water chemistry, disrupts marine life, and, more critically, signals active geological rupture. These gas releases frequently coincide with seismic tremors and newly expanded sinkholes, indicating an interconnected and accelerating process. As methane continues to rise, researchers worry about what other forces may soon emerge from Florida's increasingly fragile subsurface. Newly installed seismic monitors along Florida's continental shelf have begun detecting tremors in regions long assumed to be tectonically inactive. Florida has historically been excluded from earthquake-prone zones, a fact reflected in its building practices and infrastructure design. The appearance of seismic activity, often clustered around sinkholes and deep fractures, raises urgent questions. What is generating these tremors in a landscape shaped more by water and sediment than by tectonic plates? Are they caused by collapsing voids, shifting sediments, or something more complex? The concentration of seismic signals near geological anomalies suggests localized zones of stress where the Earth is flexing under new pressures. Combined with methane emissions and spreading fractures, these tremors reveal a dynamic system that could foreshadow further breakdowns beneath Florida and possibly elsewhere. Off Florida's coast, mapping teams identified a substantial, previously unknown fracture along the continental margin. Though the area lacks known major fault systems, this rift represents a disruption to the region's geological calm. Its alignment with methane plumes, seismic activity, and collapsed sinkholes suggests a shared origin. While scientists have yet to determine how the crack formed, they warn that such fractures can evolve, potentially developing into active fault zones. In extreme cases, this could lead to widespread land loss. If these shelf fractures propagate, a foundation once assumed stable may instead undergo a cascade of unpredictable transformations. Adding to the puzzle, divers discovered metallic objects buried deep within the seafloor. Some resembled remnants of shipwrecks or forgotten infrastructure. Yet laboratory analysis revealed that certain samples did not match known industrial alloys. Though speculation is widespread, no definitive link has been established between these objects and the surrounding geological upheaval. Their proximity to fractures and collapse zones has led to cautious hypotheses. They may influence sediment stability or mark areas of unusual geological processes. For now, each new discovery deepens uncertainty. Scientists warn that removing these objects prematurely could further destabilize an already sensitive environment. A troubling pattern has emerged from accumulated data. Sinkholes, methane releases, and seismic events are not isolated incidents. Instead, they appear interconnected. A collapse in one area often precedes instability elsewhere. The formation of a sinkhole can alter local pressures, triggering nearby fractures or seismic echoes that lead to further collapses miles away. This is not merely theoretical. Event maps show clear spatial and temporal clustering, a signature of cascading failures. If such chain reactions continue, the stability of entire coastal segments may be at risk. The implications extend far beyond Florida. Coastal cities worldwide, from Miami to New York to rapidly growing Asian megacities, share key vulnerabilities: soft sedimentary ground, dense construction, and exposure to rising seas. Increasing subsidence is being documented globally, often unnoticed until minor collapses escalate. Urban centers are watching Florida closely. What was once considered an unlikely scenario for well-monitored cities is now a tangible concern. Planning and mitigation strategies worldwide are now shaped by the unfolding situation along Florida's unstable coast. Florida's beaches are closing, not due to storms or surges, but because of hazards emerging from below. Shifting sands, newly opened sinkholes, and sudden inflows of brackish groundwater mark the terrain as unstable. Traditional sea level rise models predict gradual encroachment. Here, however, the land itself is yielding first, creating pathways for seawater to flood newly formed underground voids. Beaches once reliable are steadily retreating, with large areas periodically sealed off as scientists scramble to evaluate subsurface conditions. The threat is no longer just the sea advancing, but the land withdrawing. Each collapse sends ripples far beyond its origin. When the seafloor slumps, pressure imbalances spread outward. Rocks fracture, sediments shift, and seawater infiltrates spaces once sealed. Scientists admit these sequences often defy prediction, confounding established risk models. One hazard triggers another, creating expanding circles of instability. For residents and planners, the challenge is enormous. If experts cannot reliably forecast the next failure, how can risk truly be managed? Hidden collapses beneath the seafloor eventually manifest above ground. Subsurface voids undermine beachfront buildings, highways, and utilities. Leaning structures, fractured roadways, and sudden inland flooding increasingly mirror offshore changes. Florida's porous foundation, long recognized as vulnerable, now appears even weaker. Engineers fear that unseen breakdowns offshore could abruptly reveal themselves on land, threatening homes, businesses, and infrastructure across the coastal zone. Decades of relative calm fostered overconfidence in Florida's geological stability. Attention focused on hurricanes, erosion, and rising seas, while deeper processes received less scrutiny. Models assumed subsurface stability. Now, with sudden fractures, methane releases, and sinkholes appearing, it is clear those assumptions were incomplete. Florida's experience highlights a sobering truth. Even the most studied coastlines can conceal disruptive forces. Florida's public image suggests permanence and safety, but geological records tell a different story. Sediment cores reveal past collapse cycles, buried forests, abrupt sediment layers, and vanished shorelines. If history is repeating at an accelerated pace, both science and society must adapt quickly. Florida's destabilization has become a global reference point. Cities like London, Jakarta, and Lagos are built on similarly vulnerable ground, shaped by human activity and natural forces. Heavy construction, groundwater extraction, and unchecked development amplify subsidence risks. Florida is not an anomaly, it is a warning. Geological processes, often ignored, must now be integrated into long-term resilience planning worldwide. As mapping continues, some seafloor fractures appear to extend and merge, suggesting the early stages of rift development. Such processes usually unfold over thousands of years. Here, initial changes appear alarmingly rapid, though still theoretical. The possibility of lasting geological transformation underscores the urgency of continued monitoring. Monitoring systems reveal methane emissions pulsing in sync with new sinkholes and fractures. Each release weakens surrounding sediments and broadcasts detectable signals over great distances. Methane is not just a symptom. It may actively contribute to further collapse. As gas pressures fluctuate, predicting safe zones becomes increasingly difficult, forcing scientists into constant vigilance. Florida's continental shelf, once broad and stable, now shows measurable loss in certain areas. These changes are visible: retreating shorelines, flooded marshes, shrinking beach access. Community identities rooted in coastal life face growing uncertainty. Behind dramatic collapses lie countless minor failures: fine cracks, faint tremors, small methane leaks. Individually insignificant, together they erode stability. Engineers know that neglected micro-failures can trigger sudden, catastrophic breakdowns. Florida's situation demonstrates how cumulative disturbances can tip a system from apparent stability into rapid collapse. Urgency is mounting among scientists, officials, and residents. No one knows when the next major collapse will occur, but indicators multiply. Models increasingly point toward continued instability. The Gulf is no longer silent, it is restless. Each new data point sharpens the question: is this the prelude to irreversible change? When the red alert sounded, many expected storms or floods. Instead, the danger emerged quietly through shifting sediments, rising methane, and the slow rewriting of coastal boundaries. Florida's story now belongs to every city perched between land and sea. Each report is both lesson and warning. The coast remains for now, but its margin narrows with every tremor, every collapse, every overlooked signal. If these hidden forces continue to gather, how long before familiar horizons are reshaped entirely, leaving old maps as relics of a world changed from below? If you want more documentaries exposing the dangers beneath our cities, the mysteries of Earth's shifting crust, and the hidden threats facing coastlines worldwide, subscribe now. The next discovery or the next collapse could come at any moment.